Hi, this is Nat, and this is a video lesson on how to graph multivariable equations and also how to solve a variable equation for one of its variables. We've talked before in class about how lots of equations have more than one variable. It's possible to write lots of different sorts of equations. When you have one variable in an equation, you can typically solve for that variable and figure out what that variable is. On the other hand, when we talk about an equation with more than one variable, for example this one, y equals x minus 4, this is a really simple one, you get into a situation where there's actually lots and lots, in fact an infinite number of different possible solutions. And we could list a few, and we're going to. So here's x, here's y. If x is, I don't know, 10, x minus 4 is y, so y is going to be 6. If x is 6, y is going to be 2. If x is 0, y is going to be negative 4. If x is 2, y is going to be negative 2. And we could go on and on like that forever. We never really would have to stop. There are an infinite number of possible combinations of x's and y's that make this a true equation. So one of the things we can do when we have an equation like this with infinite solutions is we can actually graph it, and that's one way to show all the different possible solutions that it has. Let me show you how. I'll start with a coordinate plane, which is basically a graph that extends forever in both directions. So it's got the standard x-axis and y-axis, and it has a standard scale. I'm still going to count consistently and space consistently, so let me go ahead and add my scale. Along the x-axis, it'll still start with 0 in the middle, and I'm going to count by ones, but I'm only going to label every other, so I'm going to go 1, 2, 3, 4, 5, 6, and I'm going to do the same thing but going in reverse order. So from the origin, I'll start adding negative numbers. So I have negative 2, negative 4, and so on. And then y-axis, same thing. I'll count by the same values as I counted for on my my x-axis. So now I have a coordinate plane. What I'm going to do next is take each of the individual sets of x and y values and treat them as coordinates. So if x is 10 and y is 6, that is a solution to this equation. This is actually a little big. I can't really use it because x is 10 and I don't have a graph that large, so I'll move on to the next one. If x is 6 and y is 2, that works too. So I come over here on my graph to the point where x is 6 and where y is 2, and those meet at a point on the coordinate plane right here, 6, 2. And then I've got 0, 4, so x is 0, y is negative 4 down here, so that's a point right on the axis. If you ever have an x or y value that's a 0, it's right on the axis. And then I've got negative 2, 2, negative 2, so 2 on the x, negative 2 on the y, so here's my coordinate right here. And you're going to notice these go in a straight line. And I draw that line to show all the different possible solutions. Everywhere that line goes is a solution to my equation. So if I pick a spot that I didn't even find a coordinate for, let's say this one, where x is 4, y is 0, well that works. X is 4, 4 minus 4 does make 0. So everywhere that line passes is a solution to my equation. And it goes on, these arrows indicate that it goes on forever in both directions. It has infinite solutions. Here's another one, same idea. I can take this and start by finding some x's and y's, some x and y values. If x is 2, 2 times 2 minus 4 is actually 0. If x is negative 2, 2 times negative 2 is negative 4 minus 4 is negative 8. If x is 0, y is going to be negative 4. If x is 3, y is going to be 2, and so on. So now I can go ahead and solve, or sorry, not solve, I can go ahead and graph these various sets of x and y's that I've found. So I've got my x-axis, my y-axis, and I'll start with 2, 0. X value of 2, y value of 0, so it's not going to go up at all, it's just going to stay right here on the x-axis. 2, or -2, -8. So over here, -2 on the x-axis, -8 on the y, and I may not have enough room to get that in. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, oh, down here at the bottom. Okay, and I've got 0, -4, 0 on the x-axis, -4 on the y-axis, and 3, 2, 3 on the x-axis, 2 on the y-axis. Once again, you're going to see that this ends up making a straight line. And everywhere that line goes is a solution to this equation. That's how you graph equations. So here's an equation that looks a little bit different. 2x plus y equals 23. I could still do this. I could just kind of figure it out, maybe pick an x value and then solve for y. But it's kind of nice when you can just kind of put an x value in and it spits out a y value. So solving for y is a nice thing to learn to do. It's just like solving for a single variable equation, except you're going to be moving around your second variable and doing other things. So you just kind of think, same as before, what is happening to x, or sorry, what's happening to y? If I want to solve for y, what's happening to it? Well, the biggest thing that's happening is that I'm adding 2x to it. So I can undo that just like I can undo anything. I undo adding 2x by subtracting 2x. And if I do it to one side, I have to do it to the other. And this is really where this is different than just solving a normal old equation. I get to get rid of it on the side with the y, and y will now be by itself. But it doesn't really go anywhere over here. It just sort of sits there and gets attached to this 23. So 23 minus 2x. And I've solved for y. From there, it's really easy to go ahead and go through my whole graphing process, plugging in numbers and finding y values. So again, I could say if x is 1, well, 2 times 1 is 2, and 23 minus 2 is 21. So my y value is 21. If x is 8, 2 times 8 is 16, and 23 minus 16 is going to be 7. And that's pretty much back to the same thing we were doing before. Here's another sort of equation that I can practice solving for a variable. In this case, I like to solve for y. What am I doing to y? I'm adding 4x to it, I'm multiplying it by 2. So adding 4x and multiplying by 2. I can undo both of those things. Same as before, I'm going to undo it in reverse. I would have multiplied by 2 first, so I'll add second. So in reverse, I subtract to undo my addition first. So that goes away, and minus 4x comes off of both sides. This is where rewriting it's really nice. So I have 2y remaining, and that equals 8 minus 4x. Finally, I'm multiplying y by 2 over here, so I can undo that by dividing by 2, and I'll divide by 2 over here as well. If we want to get into the distributive property, we can actually simplify 8 minus 4x divided by 2 as a whole, but you could also just leave it that way. Y is equal to 8 minus 4x's divided by 2. Same thing as before, I could now plug in some x values, get out some y values, and very easily graph that equation. So solving for y particularly is a nice way of making graphing a little bit easier if your equation is not already y by itself. Next time we're going to get into how you can take this whole graphing idea and apply that to solving problems where you've got systems of equations, more than one thing happening. But for now, I'll post some practice problems on the website under this video, and you can do some practice with the graphing equations and solving for a variable. All right, bye.